Today is June 17th, 2011. This is my setup excuse me, that I use for taking spectrographical analysis. This here is a spectrum of a fluorspar or fluorescent type light. And this is the program is called IRIS. It's a preliminary program that I use to correct data or capture, and then from there I take it to the next program, which is called Spec, which is another astronomical spectrographical software. Anyway, my laptop. This is the spectrometer that I built, my second version, which is quite a bit better than the other one. Of course, this is the power supply that I use to operate the cell. This here, this light may be blinding you, is a spark gap. And what I do is I flow gas, hydrogen gas, from the cell. So in this case, this side here, this is the discharge line. It comes up through and bubbles through a stainless steel bubbler. The gas comes out, comes over, goes through a dryer where it separates the moisture out pretty well. Depends how many hours I have on it. In this case, a fair amount. It's not completely clean, but that's okay because it's going to help me determine this. In this case, I thought I had potassium hydroxide, but it turns out this spectrometer is indicating sodium hydroxide. So, got to get a hold of the vendor on that one. Anyway, the gas comes on down around the hydrogen and flows through this spark gap tube. You can see the hose it tees and comes through, flows through that chamber, and then back out and down this line, down this hose, to a torch. There again, that light's bothering you. Okay, there's the torch. And I'll let it have a flame going there. The whole idea of this is to utilize this spark gap to increase the energy level in the hydrogen. I have a baseline reading that I take just from the torch, and then I use the plasma that it generates, the electrical discharge, with the hydrogen gas flowing through there, to increase the energy levels in the hydrogen. And that's the whole plan here. It's been a while putting this all together. This spectrometer, I guess you would class it as a medium resolution spectrometer. It does really well. This is what they call first order spectra, and these two lines are these are mercury because of the mercury, and these are other forms of spectra. Some of these are not really readily or easily identified, but you can if you spend the time. But this is 5,460 angstrom level in the green. And then we come over here and we start picking up some more. We get over here, this is another mercury, and then we come on over here, there's another mercury there, and then I keep turning the grading. Now that's the looking at the what you call zero order, looking right at the slit inside the spectrometer. And then as I turn it, hopefully I can get it. Okay, now we're into second order, which is brings a spectrometer up to about a R6000. If you notice, the lines are a lot more intense, a lot more close-up. Okay, and those are those other two lines we looked at a little bit ago. Now you can see how much more brighter they are. Where this is in the 6,000 range, angstrom level, right in this area here, and this is where we're going to be looking today at the hydrogens. Here's a close-up of some lines. We're starting into the third order. So anyway, I'll get back over here where I need to be initially. By the way, I can adjust See how thick these lines are? Now I can reach inside here and I can control that optical slit. Let me narrow them down. As you can see, and then there's a focus right here. See how I narrowed that right down? Allows me to adjust the spectrometer for the various line profiles. There again, 547. They're down into the 4,000 range. About a little over, right at 4,050 angstroms. Now I'm swinging it. There's the optical slit again, and then we're going on the other side of the grating. By the way, this grating has 1,200 lines per millimeter scribed into it. It's very, very precise. Very expensive, by the way, too. That's what makes this spectrometer very accurate, is because of the capability of the grating. So anyway, it kind of gives you an idea. What I'm doing is I'm turning this knob, which turns the grating, and the light reflects off of the grating at specific angles, and those angles diffract the light. In this case, you know, the different wavelengths that I'm looking at. So we're going to come back over here and get into the, okay, we're in the 546. We want to come back over into the into this range here. So we're going to stop the video here, and I'm going to do some work, and then I'll probably record some videos, and then I'll take it to the next level. And I'll, you know, produce a video of the actual hydrogen spectra and so forth, and maybe show how I go about calibrating and identifying the lines and such. So that's it for this go around. Adios.